Algebra II 5.6 Guidelines to Factor Any Polynomial. Now, you need to have watched the previous 7 videos that talked all about factoring, all the different ways of factoring. Okay? If you didn't, you're probably going to become lost or confused. This lesson is only a review. To completely learn how to factor polynomials, you need to watch all 7 previous videos. So we're going to cover choosing the best factoring method in this lesson, of choosing the best one of all the ones we've learned. So the basic guidelines to factoring that we've learned is 1, you always look for a common factor that can be factored out. 2, you pay attention to the number of terms in the polynomial. If there's 2 terms, you factor as a difference of 2 squares. If not, you can try factoring as a sum or difference of 2 cubes. 3 terms, well, is it a trinomial square? If yes, then factor as a square of a binomial. If no, we'll test the factors of the terms. If there's more than 3 terms, try regrouping it. Try differences of squares again. And the third thing we want to make sure we do is to factor completely until each polynomial is prime. So our first one here, we ask ourselves, is there a common factor? Yes, 10x. We can pull out the 10x and we put it in front of the parentheses. And the only thing that's left over is an a squared minus a 4b squared. That goes in the parentheses. This has 2 terms, and it's the difference of squares. Because we have a minus sign here, it's the difference of squares. They're both squared. This is a squared times a squared, and 2b times 2b. We get a plus 2b, a minus 2b. And yes, we've factored each completely because each one is prime, okay? We went over that in 5.4c. All right, is there a common factor? No. We've got an x and a y. There's no common factor. This can be broken into x to the third times x to the third, and this is y to the third times y to the third. This is the sum of cubes. This is the difference of cubes. The difference of squares becomes the sum of 2 cubes and the difference of 2 cubes. We can factor this out as 1x times an x squared to get that x to the third, can't we? So we have x plus y and x squared minus xy plus y squared for this sum of 2 cubes. And for the difference of 2 cubes, we get x minus y times x squared plus xy plus y squared. Each is factored completely. Each factor is prime. In this one, is there a common factor? Yes, 10. 10 times x to the 6, 10 times 4y squared. We put the 10 on the outside. We put the x to the 6 plus 4y squared that's left over in the parentheses. This is the sum of 2 squares, and it can't be factored anymore. It's factored completely. So, I know some of you are thinking, oh, but that could be x to the third times x to the third and 2y times 2y. But no, because if we did that, because it's the sum of 2 squares, not the difference, it's the sum of 2 squares. We have a plus sign here. What's going to happen is when we FOIL, the center ones are going to make this 4xy to the fourth in the center. See? That doesn't work. That's not there. So no. This is as far as we can go on this one. Okay? Now take a look at this one. Is there a common factor here? No, except 1 and a negative 1. And we can't regroup to remove a common binomial factor. But we can rearrange this so that the negative 9a squared is in the back, and this becomes a y times y. This is a 2y times 6. This is a 6 times 6. And we end up with y plus 6 squared minus 9a squared, which is y plus 6 minus 3a, y plus 6 plus 3a. And we covered that in 5.4d. So remember, if a polynomial can be factored as a difference of 2 squares, it'll have 2 terms. See? Does this have a common factor? Yes, a 2. We can pull 2 times x squared, 2 times 25a squared, 2 times 10ax. We put the 2 in front of the parentheses, and we pull our blue x squared plus 25a squared minus 10ax. And we rearrange it so it's in the a squared minus 2ab plus b squared order, so that the squares are the bookends on each side. This gives us x times x, 2 times x times 5a, and 5a times 5a. We have a trinomial square. A trinomial square will have 3 terms, okay? That's 2 times x minus 5a, which can be rewritten as 2 times x minus 5a squared. Okay? In this one, is there a common factor? Yeah, a 2. We can pull 2 out of here, here, and here. 2 times 3x squared, 2 times 10x, 2 times 8. We put the 2 in the front, and we put our 3x squared minus 10x minus 8 here. We test the factors of 3 and negative 8. It's not a trinomial square. If it were, this would be 2 times x times negative 5, and it's not a trinomial square. It's not 2ab in the center here because this would be a 25, and it's not. It's a 2 times a negative 4 or a negative 2 times a 4, see? So it doesn't fit. It's not a trinomial square. We can rewrite it as the 2 that we factored out, x minus 4, 3x plus 2. And we covered these in a few videos, similar examples. Now take a look at this one. There's no common factors except for the 1 and the negative 1. We try regrouping to remove a common binomial factor. This one can be broken into x times x squared and x times y squared. This one can be broken into x squared times y and y squared times y. And these pink ones that we factored out, this x and that y go in front of the parentheses. See? And what's left over is x squared minus y squared, which goes here, and x squared minus y squared, which goes here. That's going to give us x plus y, x squared minus y squared. See, we have 2 of these. See? X plus y, and it would be x plus y, x minus y, wouldn't it? And because we have this one here and this one here, we can just write x plus y squared times x minus y. This one, we bring it down. We factored completely. Each factor is prime. So if you're completely confused, you have to watch those videos, okay? A trinomial square will have 3 terms. If a polynomial can be factored as the difference of 2 squares, it'll have 2 terms, okay? And always start by looking for a common factor. That's the very first thing we're going to do, all right? Our next video, 5.7, we're going to talk about factoring and the principle of zero products. Now, we went over this in Algebra I, and we're going to cover it again in Algebra II. I'm going to add this video to the Algebra II playlist and links to those Algebra I videos where we talked about all of this, okay? And any of the previous videos that are linked to this lesson, okay? They're all going to be in this video's description, so you could just click on them. There's a lot of information here. If you're really confused, you need to see these 7 videos starting with 5.4a, okay, leading up to this one. It's a lot of lessons to miss, so it'd be understandable if you didn't watch them that you'd be confused, okay? So give yourself a break, take some time, veg out in front of the screen and just watch them, all right? I'll see you next video. Bye.